I think it's a natural question is why explore space? And some people have, different people have different views on this. Personally, to my way of thinking, part of human nature is to reach out and explore.
The fact of the matter is, if man stops really stretching himself and extending himself and looking out, then I think that's when civilization will begin to decline. Man just has that inquisitive nature, and it's got to be satisfied.
We're right on the threshold of really a brand new opportunity to explore the solar system and the universe and to increase the value of benefits back here on home.
SKYLAB itself, as it is presently conceived, will provide us with a capability which grows on SKYLAB, expands on SKYLAB, and provides us with an enormous capability to conduct research in space.
And of course, space exploration provides this spiritual quality. It allows you to go to the unknown and find what's there, and hopefully by doing so, you're going to improve your lot.
To have a guy there to change film, to change programs, to repoint the thing, to fix it when it breaks, to take it out and put a new one in, is in many cases not only the rewarding thing to do, but it's the cheap thing to do.
First, we've explored the moon, and we're now going to explore near space, and finally, we're going to explore the solar system. All of this, man plays an integral part.
If our children and our children's children are going to enjoy the same quality of life here on Earth as we have enjoyed in the past, we're going to have to learn how to find new resources and how to manage the ones that we have more efficiently and more effectively.
Of course, Apollo went on to take us to the moon, but it also left us with a tremendous technology to look towards the future. And as far as SKYLAB is concerned, it represents a definite turning point.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition sequence start. All engines running. We have a liftoff.
May 14th, 1973. A working laboratory. Man's first home in space, on its way to Earth orbit, there to be occupied by 3 teams of astronauts in 3 record-breaking missions. Over the next several months, a lot of theory would become fact and give rise to new theory about man, about Earth, about the physical universe. But on this day, a sequence of events began to cast doubt on even a first mission.
Of course, as soon as we could listen in on the flight director net, we realized something had happened to the lab, even though it looked like a perfect launch from where we had been observing it. The meteoroid shield ripped off about 60 seconds into the flight, and with the meteoroid shield gone, this gave us the problem of overheating in the workshop, so many different ideas in the intervening 10 days were put out as different means of being able to rig a temporary heat shield or a permanent heat shield which would allow us to salvage the vehicle.
Of course, all the NASA centers were working on it, all our contractors were working on it, and taking an active part in the discussions and the decisions that were made as to what's wrong with the workshop and how we're going to fix it. We went to Marshall to work in the water tank with the proposed fixes, talked to the engineers who were working on it, talked to the flight planners, and discussed it, of course, with management. And we actually launched on the 25th of May with 3 potential ways of covering the workshop to shade it from the sun.
About 7.5 hours after liftoff, as we were rendezvousing with the workshop, the extent of the damage became apparent to us very rapidly. We first confirmed that the one solar wing had completely left the vehicle and was no longer around. We could see the damaged wires at the hinge line. And of course, all the gold foil which normally would have been underneath the heat shield and meteoroid shield, was exposed to the sunlight, and it had darkened on the sun side considerably. Then as we got around to the side where the jammed solar wing was, it became immediately obvious to us that this little tiny metal strap that had torn off the heat shield and meteoroid shield had jammed the solar wing.
Well, the advantages which manned spaceflight offers are in the area of repair and maintenance, which we've demonstrated time and time again on SKYLAB. As a matter of fact, the whole SKYLAB series of flights would have been a failure had it not been for the ability of the first crew to repair the space station.
Pete and I went down into the workshop, installed the canister that contained the parasol in the scientific airlock. Joe was observing the deployment of the parasol from the command module.
I couldn't see the airlock itself, but I could see this funny-looking orange thing, all rolled up and skinny, come pooching out of there. And then Pete said, okay, we're going to let her go, and it just started to unfold and did a lot of flopping, and it kind of settled halfway folded and halfway unfolded.
We deployed it as best we could, pulled it back down to us about a foot off, and that was it. It worked quite well for the rest of the mission. I think on about day 4 or 5, we definitely knew that it was no longer an uncomfortable environment. It was warm, but certainly nothing that you couldn't put up with.
SKYLAB, we're reading you loud and clear over the Vanguard for 8 minutes.
Of course, not having gotten the wing out on our first attempt when we came up there, we really had about half of the electrical capability that we should have had. So it was very, very important to attempt to get that jammed solar panel out.
I think we probably wouldn't have had any SKYLAB missions had it not been for the fact that man was able to get to the SKYLAB and to make it habitable and to repair it in such a way that all of the missions were completely successful.
So Joe tried, and then we decided to tighten it up again, and I'd try, and I got under it, and boy, it broke. It let go in one big hurry, and there I was, launched into space again, free-floating, hanging on the end of this string. And, well, by the time I got straightened out again and looked around, why, there it was, out and deployed.
Thus, very early, man's presence proved to be vital. It would be so in the missions that followed.
At the proper time. But in areas where you need man's flexibility and his initiative, for instance, in the deployment of the solar wing on the first manned mission, and on the deployment of the sail that was used to provide thermal shading for the workshop on the second mission, and on our mission where we had to resurface the coolant system, or where we had to actually get out and unjam or move the filter wheel in the solar telescope cameras. That's where you need man. You need man up there when you need some freewheeling judgment. And the tasks in space that should be assigned to man are the tasks that require him to use his mind and his abilities, his unique abilities, which certainly can't be covered by programming a computer.
The reason for having a complete package of medical experiments on SKYLAB, as opposed to the case in the earlier missions where we did our medical stuff primarily before flight and then after flight, was that we were going to fly much longer than we ever had before. We were going to quadruple the amount of time spent by a human being in space, from 14 days to 56 days. And as it turned out, we did better than that, went 84 days on the third flight. The system we expected to change fastest in the body was the cardiovascular system, the heart, the blood vessels, the amount of blood in them and the way they operated. So our number one experiment to stress that system was called lower body negative pressure. Well, we didn't have gravity up there, so we couldn't stand up, and the lower body negative pressure is a substitute for gravity, a way to fake the body out. And we ran that at 4-day intervals throughout the mission, and from the very first time we ran it, it was obvious that there were indeed changes. But the encouraging thing was that these symptoms were present the very first time we did the test, and they didn't get worse as time went on. There was another major dynamic test or stress test that we used to determine our condition in flight, and that was the bicycle ergometer. You simply worked your heart, your muscles, and your lungs to the maximum capacity to see whether they all played together the same way in the absence of gravity. We found that our ability to exercise, our heart's ability to move blood around the body, the cells and muscles' ability to extract oxygen from it, and all the processes that go into a maximum exercise were completely unaffected by zero gravity.
It was also considered important to check the response of the vestibular system, or the little balancing mechanism within the inner ear. And we did this by means of a rotating chair. Now, normally when you sit in this chair and rotate on Earth and move your head, it doesn't take very long before you experience motion sickness. However, up there we noticed that after we were there a few days, it was possible to sit in this chair and rotate almost all day long with no sensation or motion sickness at all.
We took blood samples periodically throughout the flight, mainly to make sure that the hemoglobin level in the blood was maintained at a proper level and that the body was responding properly to lowered levels of hemoglobin or red blood cells, to make sure that there was not some sort of subtle effect taking place in zero gravity that would leave us more or less open to infection, say.
On our mission, we elected prior to the launch to increase the exercise period from an hour to an hour and a half. And this was done mainly on the basis of recommendations of the previous crew. They felt there just was not enough time for a good exercise period, that you really needed more time. We were also bringing up the little treadmill, which was going to require time for use, so we just ended up going for an hour and a half per day exercise. It appears that that decision was a good one, because we came back, I think, in better condition than has any other crew.
The SKYLAB medical experiments were perhaps one of the most important things we did during the whole SKYLAB mission. We attempted to take a look at man as he reacted under long-term weightlessness. Whether or not we can extrapolate that 84 days out to several hundred days, incidentally it takes something like 400 days for a typical Mars mission, we don't know right now. But it does indicate that we're on the right way to in assuming that man can exist for long times at zero G.
The sun turns out to be a giant astrophysical laboratory. It is made up of plasma, that's high-temperature gases, which we plan to use down here for many schemes in energy production. And we can use the sun as a laboratory to better understand how plasmas are affected by electric and magnetic fields, how they're moved, what their properties are.
There were a number of really fascinating views available from SKYLAB in the area of the solar study, some of them seen for the very first time by human eye. In this case, there was an eruptive prominence on the disk of the sun, which cast out through the solar atmosphere, called the corona, to very, very high altitudes, an expanding gas bubble. This was moving out through the corona at a velocity of about 300 miles per second. And we've brought back a number of very fascinating views of these sorts of events.
Well, on our flight, we were fortunate enough to be able to, first of all, record a solar flare from the very beginning all the way through the rise to the end. Based upon the previous experience of the other crews, we were able to figure out what happens before a flare, then beyond target, and getting data as the flare came up.
We also know that when these large flares erupt on the sun, they throw out charged particles which reach the Earth in some 24 to 48 hours. These produce aurora, which we see here on Earth.
Well, the observation of Comet Kohoutek offered an unprecedented opportunity. It was very bright, and most notable was a sunward spike, which was in the opposite direction of the tail, very sharp and pointed towards the sun. Comets are important to science because we are able to observe what we think is primordial matter. That is matter which has been around since the birth of the solar system, if the comet came from the solar system, or if it came from outside the solar system, then it's an opportunity to observe something which was not created with our solar system, but in the regular stellar scheme of things.
We also had several smaller experiments intended to look at the ultraviolet radiation coming from stars throughout the galaxy in which we're in, as well as radiation coming even from other galaxies. And these experiments were extended out the scientific airlock of the SKYLAB and looked at the ultraviolet radiation coming from the sun, allowed it to be dispersed so the image actually looks like it has a long tail on it, and then he can see just what radiation is coming from each of these stars.
Throughout the 3 manned missions, flight crews evaluated the day-to-day activities of living to see what might be improved in future spacecraft design.
Mobility was, I like to refer to it as the Peter Pan mode. You could really just push off and move around within the workshop. The thing that surprised me most was how quickly we all adapted to being fairly precise.
It's very much like the sensation you get when you're skin diving or just floating around in the water.
Well, as far as working in zero gravity and moving yourself, it was a delight in comparison to 1G on the surface of the Earth.
Once your eyes see something, then you relate to it and you say, whatever is above my head is up, whatever is below my feet is down. Doesn't matter whether it's the floor or the ceiling.
Every evening, after dinner and all the work was done, we always had to take a trip or two around the water ring lockers or just go up there and free fly.
We also found that we could have quite a bit of fun doing tricks and stunts and flips and rolls that weren't possible here on Earth. Food aboard SKYLAB was a very good treat when compared to earlier space missions. Probably the best feature was the fact that we had the ability through a warming tray to put all of our food out and heat it so that when you sat down to eat, you could eat a variety of foods all at once. Probably the favorite of everybody's up there was ice cream and strawberries.
Of course, it was necessary to clean house up there once in a while, too. All of our air was filtered through a big screen within the orbital workshop. And as the air went through this screen, little particles would collect on the screen, small items that needed to be vacuumed up. And so every day or two, we would vacuum off the screens.
We found housekeeping to be not as difficult as here on Earth. One reason was that we had a planned place for every item.
Personal hygiene-wise, it was necessary for us to perform up there about the same way it is here. We brushed our teeth, we combed our hair, we shaved, we washed. We did have a shower. We found, however, that we could almost keep clean enough by using sponge baths, by washing ourselves off with a wash rag. Although we did use the shower on several occasions, and I think for future space stations, the shower would be a good idea.
We slept in a sleeping bag-like device, which had straps across it. So once you were in the sleeping bag and all snugged up, so to speak, well, you felt very close to what you feel like in bed on Earth.
We had on board, of course, EREP, which is an abbreviation for Earth Resources Experiments Package. The primary purpose of this package was to evaluate the techniques and equipment to be used in studying the Earth's surface.
The Earth Resources multispectral camera consists of a battery of 6 cameras all pointed at the same place on the ground. Now, through using suitable filters on the front of these cameras and putting different kinds of film in there, some susceptible to visible light, some that'll measure infrared light, some that'll measure other frequencies of light, you're able to record what is being radiated from the ground in these different frequency ranges.
There's been a lot of significant data gathered in the area of determination of faults. The Southern California area, of course, has been troubled with earthquakes for many, many years, and we're just beginning to really understand the fault structure in that area. We also have got some excellent photography of the fault structure as it extends on down into Baja California. Then over in New Zealand, we got some of the Alpine fault. And we think that possibly better knowledge of the fault systems around the Earth will give us a better understanding of earthquakes, and we can learn to better predict earthquakes.
You can imagine that if we had the ability to forecast weather, literally millions and millions of dollars in crop savings alone would result. And it's just the first step, of course, of weather control.
We've been able to give them three-dimensional looks at cloud formations in the areas of cyclones, typhoons, hurricanes, and the like. We've given them some photographic data that we think is going to answer a few questions that have never been answered to date anyway on just exactly how the Earth and its atmosphere interchanges energy back and forth.
Food supply is a very important factor for all of us here at home, not only in this country, but for the entire world, of course. First of all, we can survey the amount of land that is devoted to the production of these crops. We can even estimate what the yield is going to be, depending upon what its temperature and rainfall and so on is. Also, we can see where there may be areas of infestation. These instruments photograph the Earth in a variety of different spectral ranges, clear down into the infrared. In other words, some disease like a corn blight may have been started. We can see areas where the forests have had significant infestations. So this all goes together to help us put together a better pattern of the total world production of food and other things of interest to people in this country and overseas as well.
We took a good look at the Falkland Current. We could see some of the staining, this plankton blooming, the little organisms that grow essentially in the deep water, and then when the water wells up from below, it brings up this green plankton, and from space it looks like a green stain.
The plankton is sort of the bread of the sea, and it starts the life cycle in the sea. And if you can track the plankton, you can track the smaller fishes, which are going to track the larger fishes, the food fishes, which are good for commercial people.
We took some excellent pictures of the drought area of Central Africa, trying to discover the total pattern of the drought, to see if it could be stopped in some way by suitable planting, or suitable cultivation, or preventing cultivation of certain areas. So although we don't know the full techniques that would be used in this case, at least we can get a sort of a handle on food production and enhance it in some way.
As far as man-made pollution, I think that probably the most outstanding visual evidence of this is in the Great Lakes. And it starts at the source of the Great Lakes, the western end of Lake Superior, where you can see pollutants along the southern shore of Lake Erie. You can see where every large creek or small river empties into the lake.
We noticed in areas like Mobile Bay and the mouth of the Mississippi River and several other river areas around that you could see the silt moving out into the various harbors and bays around the world. Part of this, I think, we can probably blame on man because of poor soil conservation practices upstream.
Much easier to take a picture or to look down from orbit and try to survey the situation and find the areas most likely to be sites for future oil fields, for example. We think that this technique is going to make quite a lot of energy sources available that just haven't been discovered yet because of the vast surface of the Earth.
The Earth, the Sun, the stars, prime targets for SKYLAB investigations. But within the workshop, too, experiments and demonstrations covered a broad range of science and technology. In early February 1974, the third crew retrieved for the last time the film, magnetic tape, the samples and specimens for return to Earth. The operational phase of SKYLAB was nearing a successful end. The ongoing science phase, fueled by the aggregate of data from all three missions, would last for the next several years.
Say goodbye for her. She's been a good bird. Roger, sure has. Okay, guys, ascension at 1608. Roger, group.
I don't think there's any real limit to how long man can stay in space, as long as he never loses sight of the fact that sometime he's going to have to go back to 1G. And if he keeps that in mind and keeps his cardiovascular system and his muscles and his bones toned for that eventuality, then there's no reason to believe that man need worry about how long he spends in space. I don't think there's a limit to that.
We all know that the Earth's resources are limited. And in order to enjoy the benefits of the resources of the Earth that we have enjoyed in the past, we're going to have to learn how to manage what we have more efficiently. We're going to have to learn how to find new resources to improve our quality of life here on Earth.
The solar physics community has about 5 years of very intensive work ahead of them. We have brought back so many thousands of pictures, and this is actually on the order of 100,000 photographs now of the sun, which they have to look through and analyze in order to better understand all of this activity that's going on the sun.
Also, we have operated very extensive and complex equipment in SKYLAB and established that this is a viable operation, that you can do it. We have learned from SKYLAB exactly what features are best, what features to avoid in the way of designing, say, a spacecraft or space station itself, or even certain pieces of scientific equipment.
I don't think anybody really knows what man's future is at the moment. However, we do know that what man's been capable of doing, and not only has he always done it to his advantage. So I think maybe space exploration is just the beginning of man being able to go out to other areas of the universe. And once he's able to go out there, he's going to find uses for it. He's going to go out there and live, and he's going to populate it, and he's going to make a better life for himself and for the rest of the people of the Earth in doing so.